Today, what I want you to be able to do is to predict the products of a neutralization reaction. So, in your notes real quick, get this reaction written down, but don't put the question marks. Just leave that side open. All right, it's the question marks that we're going to figure out. For those of you at home, this will be our first reaction. So our job is very simple. We want to know what those question marks will be. But before we actually go through the simple process of deciding, there's a couple neutralization things that we have to understand, all of which are printed on your cheat sheet. If you look at the back of your cheat sheet, you've got a neutralization section. So let's make sure we're all on the same page on what neutralization actually is. So we know that an acid plus a base will yield salt and water. This is true, you're writing. This is true for all neutralization reactions. Now understand that it's addition, so the acid and the base can be swapped, and the salt and the water can be swapped on the reactant versus product side. Now, based on what we already know, we know that acids are compounds that start with H. We know that bases are compounds that end with OH. But what you might not know is what a salt is. It's a charge you get if you beat somebody up. A salt. It's a really good joke. It's really good. When I say salt, some of your brains go straight to this. That's table salt, one of 1,000 different salts. So that is not what I want you to think of when you see the word salt. Chemically, for our purposes, we're going to say that salt is any ionic compound. If you remember, in order to be ionic, you very simply had to be a plus bonding with a minus, usually a metal bonding with a non-metal. But in other words, one of the products of a neutralization reaction will always be an ionic compound, but we'll call it salt. And then, of course, we know that water is H2O. So, both of the sentences above and below the line say the exact same thing, and both of them are always true for neutralization reactions. So let's go to our example here. You've already written it down, but there's my acid. He starts with an H. Lithium hydroxide is my base. He ends with OH. And now we want to know what the other two guys look like. In order to predict the products, we're going to do what's called an ion swap. If I were to divide these compounds in half, I would divide them there. We have H on one side bonding with phosphate for my acid, and lithium on one side bonding with hydroxide in my base. The only subscripts I care about are subscripts that are attached to polyatomic ions. Again, first semester helps you here because a lot of you are very familiar with that list on your cheat sheet. But my point is that PO4 always has that 4, but H does not always have that 3. Nowhere on your polyatomic list can you find H3. But on that list, you can find PO4. I'm going to be repeating that point a few times because it's really important. But here's what's going to happen on the other side. It's very simple. The items that are on the left of each compound need to switch places. Let me say that again. Hydrogen, which is to the left of my split here, and lithium, which is to the left of my split here, simply need to swap spots on the other side. See if you can visualize what that'll look like. That means that over here, lithium would be right there. It'd be LiPo4. The H then would be where lithium is currently, so the hydrogen would be right there where my hand is, HOH. There's a nicer way to write HOH. What is it? H2O. Remember, water will always be one of your products in neutralization. Now, my blue lines here are not a part of the answer. That's what you do in your brain. You split the compounds in parts and then swap their positions. But that salt that you create is a new compound, kind of like a compound that you might have translated. And what do we always have to do when we translate a compound? That's right, we have to check his charges. What's lithium's oxidation state? You should have a periodic table out that I told you to at the beginning of class. What's lithium? It's a 1. What is phosphate's oxidation state? Just look at your cheat sheet. It's a 3. If the numbers are different, we crisscross. So the 3 will cross to here, the 1 will cross to there, the 1 will have no effect. And now we've done our entire job. So let me summarize what happened. It's an acid reacting with a base to produce a salt and water. We took the first part of each compound and swapped them on the other side, but then we checked the charges of the salt that we created, because that's just the habit you'll have to get into. Let's do another one. Our second example. Notice how the acid and the base are swapped on this one. The base comes first. That doesn't matter. So when you're classifying, make sure that you're aware of that. So it's neutralization. We've got iron 2 hydroxide. That's a base reacting with hydrobromic acid. And we want to know what the products are. We want to fill in those question marks. Where will I split this guy in half? Right after the iron, that's right. You can see 2 different entities there, iron and hydroxide. Where will I split him in half? All right in the only place that's really available, in between the H and the Br. Now remember what your brain wants to do. We want the Fe and the H to swap spots. If that happens, what will be bonded with the OH on the other side? The hydrogen. Hydrogen came over here where my hand is, and now he's with OH. HOH or H2O. This 2 right here, and this is the part that your brain will have to really focus on, does not come with the party. Nowhere on your polyatomic list is there an OH2. The only subscripts that will automatically go over there are ones that are attached to polyatomic ions, like in the PO4 in the previous example. We've got another compound over here, though. What will be with bromine on the other side? Iron. The Fe came over here to where my hand is, FeBr. And what's the very last thing I need to do? Check salt. All right? Check this salt and make sure that the subscripts are correct. Now, this one tries to be a little bit trickier, because when I say what's iron's charge, when you go and look at the periodic table, you don't know. But if you go and look back over on this side, iron's charge will stay the same. What's iron's charge over here? It was a 2. That 2 came from iron. So iron will have a charge of 2 here as well. What is bromine's charge always? Find it. Find bromine. 1. Bromine's -1. The numbers are different, so 1 crosses to Fe and nothing happens. 2 crosses to bromine and that happens. Again, all the blue stuff I wrote here is not a part of the answer. It's just what your brain is thinking. What do you think of this so far? Here's our third example. Let's see how you did. First off, I do hope you notice why some of these subscripts exist that we don't bring over. The whole reason this H has a 2, even though he doesn't have a 2 on his own, is because carbonate CO3 has a 2. So when I built the example for you, I of course wrote it correctly. This 2 crossed over, the 1 crossed there, nothing happened. The same here. Calcium's predicted charge is a 2. So when that crossed to hydroxide, well, that was a number bigger than 1 crossing to a polyatomic, so we needed parentheses. So anyhow, the reason that some of these subscripts that are not essential are over here is because that's what the chemistry is that we've already learned. I know this is neutralization because it's an acid reacting with a base, so I'm going to do an ion swap. The 2 guys that will switch places are going to be hydrogen and calcium. I just want them to switch spots on the other side. So calcium then will be right there with CO3. Hydrogen will be right here with OH. HOH is the same thing as H2O. 2 H's and an O. The 2 did not automatically come. There's no such thing as OH2 on my polyatomic list. That 2 didn't automatically come. There's no such thing as H2 on my polyatomic list. But don't forget to check your salt. Calcium's predicted charge is +2. Carbonate's predicted charge is -2. And even if you forgot to check your salt on this example, you would have still gotten it right. Because when they're the same number, we don't crisscross. Anybody get a different answer? Now, that is the entire neutralization skill. The idea now is that when you identify something as neutralization, as we've done the last few periods, you're now able to say, oh, well, since it's neutralization, I know I do an ion swap and I'll get salt and water. The other 2 reactions will have different things that you do after identifying them. But before we call it a day, I have a challenge for you. Here's our challenge problem of the day. Now, just by looking at that one product, you couldn't say that it's neutralization. It could be a bunch of different things. But if I tell you it's neutralization, fill in the rest of the question marks. See if you can fill in the rest of the question marks. So let's see how you did on the challenge problem. All it gave you was 2 bits of information. It said that it's neutralization, and it gave you salt. Sodium dichromate. Hopefully you were able to find the sodium dichromate, because if you didn't know where to split him, then you'd be very confused. So let's see what information from my neutralization equation I can fill in right away. What's the other product? It's got to be water. So we know that. Now keep in mind, in order to get these products, there was an ion swap that took place. So in order to find my reactants, I would simply need to undo the ion swap, which is kind of the same thing. I would need to move the pieces back to where they started. So if I were to, again, split this, I would split this guy right there. The only way that you would be able to see that, though, is if you realize that Cr2O7 is polyatomic. He's on your list. It's dichromate. and then this guy would be split here. So if the Na and the H were to swap positions, then the H would come over here and be with Cr2O7. H, Cr2O7. And there's my acid, dichromic acid. The Na would come over here with the O, right where my hand is. So it looks like it would just be NaO. There's something wrong with that, though. What's wrong with that? It's got to end with hydroxide. So there's actually another H there. Remember, I said it's neutralization, therefore it must be an acid reacting with a base. But we need to check both reactants in this case, because both of them could have numbers we're unaware of. Hydrogen is +1, dichromate is -2, and the values are different, so the 2 will cross to there, and the 1 will cross to there and do nothing in that case. Sodium is +1, hydroxide is -1, they're both 1, so who cares? And now we have solved our problem. Anybody get it? Yay! You missed that too? You see why? Good. Any questions over neutralization?